Once again, we're back and we want to check problems on hyperbolic functions. And on hyperbolic functions, we shall look at on proofs. We shall look on proofs, and also again we shall look at on problems, on hyperbolic functions. So please share and subscribe to the YouTube channel. We are about to start on hyperbolic functions. Revision on hyperbolic functions. So on question 1, we shall have a proof question. So revision question 1 on hyperbolic function. Question 1, we have prove the hyperbolic identity. Prove the hyperbolic identity. Hyperbolic identity 1 minus the tan hyperbolic squared of x is equals to sec hyperbolic squared of x. So I can advise you, if maybe you have not checked my video on hyperbolic functions, I've already provided a video on hyperbolic functions. So in this video, you only want to solve problems on hyperbolic functions. And an example we have here is a proof the hyperbolic function or hyperbolic identity 1 minus tan hyperbolic of x. We have two methods of proving hyperbolic function. The first one on solution, we have two methods of proving an hyperbolic identity. So the first method, it is you can substitute or maybe replace. You can replace CH of x with its definition, which is x plus exponential negative x all over 2, and SH of x with exponential x minus exponential negative x over 2. Kindly guys, members, share the link to your friends so that they can also, both of them come here and benefit from the same. So if you have a group, a WhatsApp group, that these students are doing engineering, or also again they are either doing maybe some courses that in mathematics and they do hyperbolic functions, kindly I welcome them. I welcome them to this live so that they can also benefit on the same. So thank you very much. So we can proceed, and if you have not subscribed, kindly subscribe and you share. Kindly subscribe and share. And if you get a chance to put a comment, I will appreciate. So thank you very much. So let us continue with our question. So we have said we have two ways or two methods of proving an hyperbolic function. And the first method, we have said, it is by replacing the cos hyperbolic with its definition, which is exponential x plus exponential negative x over 2, and the sine hyperbolic of x with its definition like that. The second method The second method that we have is by use of Osborne's rule. By use of Osborne's rule. So the Osborne's rule simply states that for every trigonometric identity or trigonometric ratio, there is a corresponding hyperbolic identity, and therefore that you can substitute them. If maybe it is cos, you can substitute with cos hyperbolic, and if it is sine, you can substitute with the sine hyperbolic, and if it is tan, you can substitute with the tan hyperbolic. But maybe wherever you have a direct product of sine or indirect product of sine, then the sine hyperbolic, the sign of that sine must change. For example, what we mean by that, we say that if maybe you have something like sine squared of x, a corresponding hyperbolic hyperbolic function will be negative sine hyperbolic of x. So that's what you mean by if maybe it is direct or indirect. For indirect, you can have a case maybe like tan squared of x. So you know this one is the same as the sine squared of x over the cos squared of x. And now this one implies that the corresponding tan squared hyperbolic of x will be corresponding tan hyperbolic of x will be the negative sine hyperbolic squared of x over cos hyperbolic squared of x. So this implies that the corresponding tan squared of x, it will be negative, which is just negative tan hyperbolic squared of x, like that. So, but now in this one, the solution of this question, so let us have the basic solution for this question. So maybe what do you think that now in this question will be? Which method are you going to use? Is it hyperbolic function, or is it now the first method or the second method? Is it the first method or the second method? Maybe you can put in the comment section, and then maybe you can tell whether which one it will be easier for you to understand. But either way, you can use any of them. So in this case, let us just apply the first one so that we can substitute. So we have now the solution in bracket, solution of our proof. So our proof is to show that 1 minus the tan hyperbolic of x is equals to the sec hyperbolic squared of x. So as we usually state in trigonometry, that tan x is equals to sin x over cos x, then still we need to remember that th of x, the tan hyperbolic of x, is also the same as the sin hyperbolic of x over the cos hyperbolic of x. Hyperbolic functions and trigonometric functions are related to some extent. We shall come to check on what is the relationship between the hyperbolic functions and trigonometric functions. But as we usually state, that tan x is equals to sine x over cos x, it corresponds just the same as tan hyperbolic of x being equal to the sine hyperbolic of x and cos over cos of hyperbolic of x. Also, again, the sec hyperbolic, we know that sec x in trigonometry is the same as 1 over cos x. Also, again, the sec hyperbolic of x is still equal to 1 over cos hyperbolic of x. So you can see there is kind of relation. So I want us to substitute. Remember our area, it is to show that 1 minus tan hyperbolic of x is equals to sec squared of x. So you can simply go by this. We say 1 minus the tan hyperbolic of x will be the same as what? It will be the same as it is the same as not negative as such. So this would be the sine hyperbolic squared of x over the cos hyperbolic squared of x. So let us see whether this is true. Is tan hyperbolic of x the same as the sine squared hyperbolic of x? Do you think it's the same? So what do you say in the comment section? Okay. Now this one here, it will be negative. Reason why? Look at here what you said, that we have this, and so therefore you can have something of the sort like that. So on that basic proof, we are going to have what do you say? Go to the comment section. Let me see what you're going to say in the comment section. In the comment section. So is it going to be negative sine squared, or it's going to be just sine hyperbolic of x or over cos squared, cos hyperbolic squared of x? Yeah, tell me in the comment section. So what do you think? Okay, it's all right. So we can just continue, no problem. Now, so what is the LCM? If you can open up this bracket, you're going to have 1 plus sine hyperbolic squared of x, or over, no, it's not. This negative should not be there. So you're going to have, let me just erase this one, because we are substituting from this function. So we're just going to have 1 minus the sine hyperbolic squared of x, or over cos hyperbolic squared of x, like that. So the LCM is going to be the cos hyperbolic squared of x, and so you're going to have, if you take the cos hyperbolic squared of x, this is over 1, so you're going to have cos squared hyperbolic of x, which will be just ch squared of x, like that. So if I take the ch squared of x, I divide by ch squared of x, it will be 1, then multiply by sine hyperbolic of x, so you're going to remain with minus sine hyperbolic squared of x. Now we need to say something here. We have the trigonometric identity, trigonometric identity that states cos squared x plus sine squared x is equals to 1. and you know that's a basic identity in trigonometry. Let us apply the Osborns to transform this one and see what is the corresponding hyperbolic identity. So we're going to apply Osborn's rule to obtain corresponding hyperbolic identity. So cos squared will remain to be ch squared of x. But we said the sine squared of x, wherever we have the product of sine, then the sign is going to change. So in this case, we have positive sign here. In this case, we have the positive. You can see this one is positive. So from Osborn, this positive is going to change to be negative. So it will be negative, then the sine hyperbolic squared of is equals to 1. So this implies now from our problem here, we're going to 1 over ch squared of x. But in the beginning, we said that ch squared of x, which is just the same as 1 over ch of x. 1 over ch of x is the same as what? The sec hyperbolic of x. And so this proves to us that you're going to have 1 over, you're going to have the sec, to be sec hyperbolic of x squared, which is equals to what? The sec hyperbolic squared of x. We don't open as we usually open the indices. So for trigonometric and hyperbolic functions, square the function like that, or maybe we raise the power the way we have raised in this. Thank you. So you can be able to see the end of our proof. That's the end of our proof. That's 1 minus tan hyperbolic of x is equals to sec hyperbolic squared of x. That is the end of the proof. Do you have any question? Kindly make sure you share. Make sure you give it to your friends who are pursuing the same course or they are doing some mathematics. And also kindly like, subscribe, and then you comment. Thank you so much. I send those for you guys. Thank you so much. So I want us to do, I want to give you an example, not an example as such. I want you to try, and then you tell me whether you'll be able to do. But again, in some few minutes, I'm going to do it, to do the question. So the question number 2, we have question number 2 here. Question 2, we have done, that is question 1 of the proof. So we have question 2 of the proof is that prove that 1 plus 2 the sine hyperbolic squared of x is equals to ch of 2x. So we are going to use the first method as we suggested, solution. So in the first method, we said we substitute or we replace ch of x with its definition. The definition was ch of x equals to exponential x plus exponential negative x over 2 and s squared of s of x, that is sine hyperbolic of x is equals to exponential x minus exponential negative x over 2. So this implies that s h squared of x will be equal to exponential x minus exponential negative x all over 2 and all of it squared. So we're going to have, so we substitute, so we're going to have 1 plus exponential, so we're going to have the 2, then you have exponential x minus exponential raised by negative x, this one squared, then over 4, which is 2 squared. Then from there we have 1 plus, so you can simplify by 2 1 by 2 2, so we have 1 plus exponential x minus exponential negative x squared over 2. So maybe I can let a be equal to exponential x and b be equal to exponential negative x, then what will be a plus b squared? This will be equal to, it will be equal to what? Good. So it will be equal to a squared plus 2ab then plus b squared. You are right. So we substitute, we're going to have 1 plus a squared minus, so for us we need a minus b, so we don't need a plus b. So we're going to have, for the a minus b, it will be equal to that. So a minus b squared will be equal to a squared minus 2ab then plus b squared. So, and that is it. So we're going to have, when you substitute, we're going to have 1 plus a squared minus 2ab plus b squared, and all these it's over 2. So if you can check the LCM, so we're going to have, the LCM is 2. So 2 divided by 1, it will be 2. 2 times 1, it is 2. Then 2 divided by 2, it is 1. So times a squared minus 2ab plus b squared, it will be plus a squared minus 2ab then plus b squared. So from there we can substitute back our a's and b's. So we're going to have 2 plus, now a squared, if a is equal to this, then a squared is exponential 2x, because we multiply the powers. We multiply the powers. If you can remember how we do that, say that if a is equal to exponential x, then a squared is equal to exponential x squared. So from indices, we multiply the powers, so you get exponential 2x. So that's why we have put our 2x here. So and then we proceed, minus 2 exponential x, exponential negative x, then plus exponential negative 2x, and all this, it's over 2. So clearly, this part here, this part, you're going to use the indices, the rules of indices. So when you multiply indices, that when you multiply the indices, that is maybe when you multiply the power, we have bases, same bases, but different powers. So what we do, we add the powers. So we have exponential x multiplied by exponential negative x. So we shall add the powers, you'll get x plus negative x will be 0. So we're going to have 2 plus exponential 2x, then minus 2 exponential 0 plus exponential negative 2x, and all this over 2. From indices again, we said that exponential is power 0 is equal is equals to 1. That is, any number raised to power 0 is equals to 1. So this part shall remain with 2. So 2 plus exponential 2x minus 2 plus exponential negative 2x. And all this is over 2. So this 2 and that 2 will go. So we shall remain with exponential 2x plus exponential x and this over 2. Now, so we need to understand how do we define CH of x, so that we see whether this one will be which. This will be equal to CH of 2x. Let us see how. So we know that CH of x is equals to exponential x plus exponential negative x over 2. So the denominator of this function is not affected. And so therefore, if I want CH of a, then it will be equal to exponential a plus exponential negative a over 2. So this means that if I want CH of 2x, then it's wherever I have a, put my 2x. So I'm going to have exponential raised power 2x. Wherever I have my a, I'm going to put 2x, then plus exponential raised power negative 2x or over 2. So that's why you can say this one here is correct. So, and that is the end of the proof. Any question? Kindly let us make an effort to like, subscribe, and share, comment. Do you have any question? So you want to go to example 3 or question number 3 on still on functions. But before we go to that, I'll give you an assignment. You go and try this exercise, or maybe an exercise. So show that the tan hyperbolic squared of x plus sec hyperbolic squared of x is equals to 1. So this one, just do a practice using it. So what you'll do, you can convert. Remember, you need to remember what is th of x. So th of x is tan hyperbolic of x. We said tan hyperbolic of x is the same as the sine hyperbolic of x over cos hyperbolic of x. So maybe in this exercise, maybe I can still do for you. I can say solution. So when you go and try, you can go and try, but the solution will be th squared of x is the same as the sine squared of x over cos hyperbolic squared of x. And also again, we have sec hyperbolic squared of x is the same as 1 over ch squared of x. So if you can substitute, you're going to have sine hyperbolic squared of x over cos hyperbolic squared of x plus 1 over cos hyperbolic squared of x. So the LCM remains the same. So you're going to have from the LCM will be ch squared of x, which is just cos hyperbolic of x. So we're going to x plus 1. But we know that ch squared of x minus sine hyperbolic squared of x is equals to 1. This is from the identity that let me just put here, from cos squared of x plus sine squared of x is equals to 1. So it is from this one that we are transforming to get that. Remember, we said you can convert a trigonometric identity to a hyperbolic identity simply by applying the Osborn's rule. That cos squared, it will be this. But for the sine, because this is sine times sine, then the sign before it is going to change. So from this one, you can have that ch squared of x is equals to 1 plus s squared of x, which is the same as s h squared of x plus 1, like that. So we can now substitute to this our function. We're going to have it as ch squared of x over ch squared of x, which is equals to 1. So that is the end of the proof. So you can see it was an easy question, I hope. Maybe you can think on how to solve it. But that is the solution. So if you use by exponential or definitions of cos, if you go by the definition of cos hyperbolic and sine hyperbolic, you still arrive at the same point, but it will be long. It will be long. So I hope now maybe we can go to another question on hyperbolic function. So I'll do two more questions, so that now you can cross for hyperbolic function. Then now you can go to some problems on differential calculus. So is there any question? So thank you very much. So let us continue to another question. Thank you so much, my audience. Kindly just make sure you share, subscribe, and make sure so that others can also benefit from the same. So I can still see we have some people who are following us from Facebook. So no problem. Thank you so much. Knowledge is to be shared. It's not to be kept. We share knowledge and we don't keep knowledge. So let us have this question. Determine the value of A and B. We have a question here. Determine the value of A and B. Determine the value of A and B when given A exponential x plus B exponential negative is equivalent to 4 ch of x minus 5 sh of x. So how do you go about this kind of a problem? So in this kind of a problem, then it means that we have to rewrite the right hand side in form of exponentials. Let me put here solution. For solutions, we use the black pen, as we said. So rewrite the right hand side in exponential forms. In exponential form. So what we mean by that is that we substitute ch of x with exponential x plus exponential negative x all over 2, and sh of x is equals to exponential x minus exponential negative x over 2. So we want to deal with the right hand side. So this implies that 4 ch of x minus 5 sh of x will be equal to 4 into exponential x plus exponential negative x over 2, then minus 5 into exponential x minus exponential negative x over 2, like that. So if you open up this bracket, so you can have by 2, 1 by 2, 2. So we're going to have 2 into exponential x plus exponential negative x, then minus 5 over 2 into exponential x minus exponential negative x, like that. So as we continue, kindly make sure you share to your friends, share to your WhatsApp groups, share the link to Facebook so that also others can also benefit. Kindly like, subscribe, share, and comment. Thank you. So we open up the bracket. When you open up the bracket, you're going to have 2 exponential x plus 2 exponential negative x minus 5 over 2 exponential x plus. The reason why it is plus is because of this minus. Negative 5 over 2 multiplied by negative exponential x, it would be positive 5 over 2 exponential negative x, like that. So from here, we put the right terms together. Put the right terms together. So we're going to have 2 exponential x minus 5 over 2 exponential x. We shall have, so 2 minus 5 over 2. We shall have negative 1 over 2 exponential x. Then now we have 2, then plus 5 over 2. Then we shall have 9 over 2, so it will be plus 9 over 2 exponential negative x. Clearly, we have a exponential x plus b exponential negative x, so is equals to negative a half exponential x plus 5, now plus 9 over 2 exponential negative x. So this implies that the corresponding, so a will be equal to negative a half and b will be equal to 9 over 2. That's the end of that question. I hope you have understood. So maybe I can take it a little bit higher so that you can see what you have written on the solution. Is there any question or any comment? Thank you very much. So let us continue. Feel free to chat. Feel free to put your comment down and asking questions. So we want to do a final question on hyperbolic function. Then I can proceed to differential calculus. So thank you very much. This is Mathematics Solutions. I'm a qualified trainer and also a lecturer. So have confidence to ask a question and I will answer you. Thank you so much. So let us go ahead and have our question. Our last question. This was question number what? This was an example, but previously we had an exercise. So let us do a final question on this. The working, it will be also available on YouTube at Mathemike Solutions MMS. Kindly share this link and some people, and it is going to help some people or students or even colleagues to understand how simple mathematics is. Thank you very much. So let us go to another question. We have a question here. Solve In fact, it is solve for x. So for x given 2.6 ch of x plus 5.1 shx is equals to 8.73, and we have a condition here, correct to 4 decimal places. So how do we go about this question? Let us look at the solution together. I've written the question down. So do we continue and check the solution to this question? Okay, thank you very much. So if you want to reach me out, you can reach me out on my email, mathematicssolution@gmail.com. So let us look at this question together. So we are saying we have 2.6 ch of x plus 5.1 shx is equals to 8.73. So remember the same way we were proving the hyperbolic identity, we want to apply the same to solve. And what I mean by that, applying the same, is simply to substitute the hyperbolic functions with definitions. So you need to substitute ch of x with exponential x plus exponential negative x and sh of x with exponential x minus exponential negative x all over 2. So with that, members, we have 2.6 into exponential x minus exponential negative x all over 2, then plus 5.1 into exponential x minus exponential negative x all over 2, and this is equals to 8.73. So if you can drop down and see. So from there, you can open up the bracket or simplify. So we can have these 2 by 2, 1 by 2, 1.3. So we have 1.3 into exponential x minus exponential, is it minus or plus? It is plus exponential negative x, then plus 5.2 divided by 2, 5.1 divided by 2 is 2.55 into exponential x minus exponential negative x. This is equals to 8.73. So from there, we can open up the bracket and put the terms together. So we shall have 1.3 exponential x plus 1.3 exponential negative x plus 2.55 exponential x, then minus 2.55 exponential negative x, and this is equals to 8.73. So if you can check this one, we can put the right terms together, the exponential x and the exponential x, and then also you can put, we also have exponential negative x and exponential negative x. So we're going to have 1.3 plus 2.55 shall have 3.85 exponential x, Then you have 1.3 minus 2.55. Then you have minus 1.25 exponential negative x, and this is equals to 8.73. So multiplying through by exponential, okay, the reason I'm saying multiply through by exponential is because we can write this one as 3.85 exponential x minus this exponential here, it has a negative. Our exponential here, it has a negative, and so therefore it can be the same as 1.25 over exponential x is equals to 8.73. So why have we bring it down? It's because, if you can remember, shall I say 1 over a raised power n is the same as a raised power negative n. So this should guide you on exponential raised power negative n, then it will be equal to 1 over exponential raised power n. So with that in mind, so I can multiply through now by exponential x. So multiply through by exponential x. So what are you going to have? So we shall have 3.85 exponential 2x minus 1.25 is equals to 8.73 exponential x, like that. So if I can let p be equal to exponential x, then I'm going to have 3.85 p squared. I can bring this one on this other side to have minus 8.73 p, then minus 1.25, and this is equals to 0. So we have already formed a quadratic formula, and we know you can solve this quadratic formula using the quadratic. You can solve this quadratic equation using the quadratic formula. So, and this means that p will be equal to 8.83 plus or minus the square root of negative 8.73 squared minus 4 times 3.85 times negative 1.25, and all this over 2 times 3.85. So we shall get the value of p being equal to I remember in the orientation video on how to solve a quadratic calculator, and you can solve this 3.73. So you can have our p being equal to 2.44027, and p is also equal to negative 0.1351, like that. But you know what is p? But p is equal to exponential x. So you can say that for p equal to 2.4027, then exponential x is equals to 2.4027, which means that x is equals to ln of 2.4027. So which is equals to x equals to, so the ln of 3.4 0 to 7 is 0.8766. So that will be the value of x. Then for p equal to negative 0.1351, it will not be possible for us to find the value of x using this value of p, because there is no the natural log of a negative value, because we'll end up having x being equal to ln of negative 0.1351, which does not exist, which does not exist. So the value of x will be, so x is only equal to 0.8766. Thank you very much. So for hyperbolic functions, there are more questions. I'll provide more questions for revision, but I want to now can proceed to, I'll prepare another video now for differential calculus, work on differential calculus. Unless you have any question, any comment, kindly subscribe and share to your friends. Thank you very much. Let us meet again on Mathematics Solution, the mathematical heaven. Thank you very much.